I call it the information theory of aging. 80% of our lifespan is determined by how we live our lives. We can turn on these survival systems and epigenome stabilizers, eating a lot less often. You can take a sirtuin activating molecule, which is resveratrol. These all work, we think, because they're turning on these defense pathways. Kind of discoveries we're making, I didn't think that we'd see in my lifetime. There's a backup hard drive of youthfulness in cells that we can access and essentially reset the body to be young again.
Welcome to the Melanie Avalon Biohacking Podcast, where we meet the world's top experts to explore the secrets of health, mindset, longevity, and so much more. Are you ready to take charge of your existence and biohack your life? This show is for you. Please keep in mind, we're not dispensing medical advice and are not responsible for any outcomes you may experience from implementing the tactics lying herein. Are you ready? Let's do this. Welcome back to the Melanie Avalon Biohacking Podcast. Today's episode, guys, I know I've been talking about it on the Intermittent Fasting Podcast for months now. That is because I had this episode scheduled originally quite a while back, booked for an hour with David Sinclair. And as it turned out, if we pushed back the recording date a little bit, I could have an entire hour and a half with him. Totally worth it. That's how excited I am about this interview. I just can't even describe how excited I am about this interview. I don't want to make the other episodes jealous, but prepping for it, recording it, everything was like the Disney World Christmas magicalness of everything I could ever want in this podcast. So please enjoy it. The show notes for today's episode will be at melanieavalon.com/lifespan. Today is also a special day because it is Black Friday. Happy Black Friday. I hope everybody's Thanksgiving was absolutely wonderful. So I will say I've actually never been excited about Black Friday. I kind of go into a cave and hide because I'm not a huge shopper in stores. I'm not a huge shopper in general. But now that I've become a quote biohacker, all of these products and amazing things I'm obsessed with are running amazing Black Friday deals. So now I actually am super pumped about Black Friday. So here are the deals that you do not want to miss. For starters, Chili Pad. They will change your sleep for the better. If you struggle with sleep temperature issues, they are a game changer. I will never not sleep without my Chili Pad. They are having a Black Friday special, which is even better if you use my code in conjunction with it. If you use the code MA25, that will get you 25% off of their Chili Pad. And if you use the code MA20, that will give you 20% off of their brand new Uller, which is their new and improved upgraded version of the Chili Pad. Second, ButcherBox. They have an amazing special going on. They provide easy, affordable access to grass-fed, grass-finished steaks, heritage breed pork, organic free-range chicken, and wild-caught sustainable seafood. They're amazing. I cannot recommend them enough. And right now, if you go to butcherbox.com/MelanieAvalon, you will get, wait for it, 8 free steaks, 2 filet mignons, 2 New York strips, and 4 top sirloins, all grass-fed. Plus, you get $20 off your first box. All of that. It is an incredible offer. It's not going to last long. Definitely jump on it. For non-toxic beauty, we discussed the science of skincare in my episode with Stacey Toth, which I will put a link to in the show notes. And if you're really looking to clean up your skincare and makeup, which is often a rampant source of easily absorbable toxins, you definitely want to check out Beauty Counter. I'm so grateful for them as a company, and they are having their biggest sale of the entire year. You do not want to miss it. It is their Clean Friday sale. It ends December 1st. Now is the time if you want to clean up your skincare. You want to get on this. They're doing 15% off site-wide, which is huge, and free shipping. Just go to beautycounter.com/MelanieAvalon. And by the way, you really want to use that link. And if you want to know why you really want to use that link, definitely get on my Beauty Counter email list. That email list is at melanieavalon.com/beautycounter. You'll learn how to get free gifts from me, discounts, and so much more. But really, guys, if you've been thinking about cleaning up your skincare and beauty routine, now is definitely the time with this sale. It's their biggest sale of the year and definitely the time to jump in. They also have a complete money-back guarantee. Also, I highly recommend you become a Band of Beauty member when you do that purchase, because then, on top of the magical thing that happens using that link, plus the 15% off site-wide, you also get a welcome gift worth over $60, plus free shipping from here on out for the rest of the year, plus an additional 10% back. So basically, everything. Now is the time. And lastly, as David Sinclair discusses in his book, energy production in the body and healthily functioning mitochondria is key for health and longevity. One of the best ways that you can support that is through red light and near-infrared therapy. Juve makes devices with the exact wavelengths you need to supercharge your cell's mitochondria, minimize oxidative stress, decrease inflammation, smooth over your skin, reduce muscle pain, regulate your circadian rhythm, and so much more. I cannot recommend these devices enough. I am obsessed with them. And they are having, for the first time ever, they have never done this before, ever. This is huge. They are having a Black Friday sale. Guys, they don't do sales. I mean, they might in the future, but this is actually like a really big deal. When they reached out and told me they were doing this, I was shocked because this is a first time for them. The special runs Black Friday through Cyber Monday. It's going to be limited time only based on inventory, and it is $100 off the Juve Mini, which is what I started with and I adore, or $200 off their Solo, Duo, Max, Quad, or Elite. That's limited to one-time use per customer. To get that discount, plus a free gift from me, just go to melanieavalon.com/Juve Friday. Again, that's melanieavalon.com/Juve Friday, or you can use the link in the show notes. And then to get the free gift from me, use that link and forward your proof of purchase to podcast@melanieavalon.com. I am a Himalaya partnered show, and if you'd like early access to this podcast 24 hours in advance, just follow me in the Himalaya app. Also, please join me in my Facebook community. That is Paleo OMAD Biohackers, Intermittent Fasting plus Real Foods plus Life. It's a wonderful world of all things biohacking, longevity, lifespan, intermittent fasting, so many things. So definitely join me there. Now, without further ado, please enjoy this episode with David Sinclair. Hi, friends. Welcome back to the show. I have been looking forward to this episode for months. I can already say it's probably my favorite episode. I'm just so excited to be here. I am here with David Sinclair. The man honestly needs no introduction. He is a professor in the Department of Genetics and co-director of the Paul F. Glynn Center for the Biology of Aging at Harvard. He is the co-creator and co-chief editor of the journal Aging. He's been nominated in Time Magazine's list of the 100 most influential people in the world, as well as their top 50 in healthcare. He's all over the place, the Today Show, all the news outlets, all the podcasts, and he has a new book, which I think is probably the only book I own in every format available, print, Kindle, and Audible, and that is Lifespan, Why We Age and Why We Don't Have to. And then lastly, I tell my parents and my family about every guest I'm having on this podcast, and my dad has never heard of anybody. He had heard of you. So that is that is a big deal in our family. Thank you so much for being here, David.
Oh, Melanie, thanks for that introduction. Well, it's all downhill from here.
No, not at all.
No, it's an honor to be on here, and I've followed you on social media, and I know your book, your latest book. It's and we actually share the same agent. We've just found out, so we have a lot in common, actually.
Yes, it's a very, very small world, and you speak to my obsession in life, which is the mechanisms of aging and lifespan. And for listeners, if you guys, most people now are pretty familiar with the compound resveratrol and the health benefits of red wine. It's quite likely that you know about that because of David's work. You've contributed so much to the health world, and super grateful for your work.
You're welcome. Sales of red wine went up 30% when we published in 2006, and they've stayed up. So everybody who enjoys a glass of red wine, you're welcome.
I know, it's amazing. I will say, first of all, though, your Audible version of the book, I was so thrilled that you narrated it because I'm an audiobook recorder myself. I'm a huge consumer of audiobooks, and I love it when authors narrate their own books. Hearing you read Lifespan, which by the way, Lifespan, it's a very dense book. Well, dense in a good way. It goes very intensely into the science of aging. It's very scientific, it's very technical, but it's also a beautiful book. It's very poetic and you can really hear your voice coming through. So hearing you narrate it just really made it such an approachable book to a subject that I think a lot of people can find very daunting. Yeah, what was your experience like recording that?
Well, it's tough hearing your own voice. I think everyone feels that way. But it was the right thing to do. I had advice from Joe Rogan in particular. He said he'll be very angry with me if I don't read this book myself. And then I thought, what would it be like if someone read it and I didn't like it? Then I'd kick myself. So I spent 4 days in a studio. Uh, Two of them were in LA, two were in Boston. And it's pretty easy when you start reading a book. And I enjoyed that. But after you've done it for 4 days, it's pretty hard to keep up the enthusiasm. And it's not just one take. It's, let's go back. The editor is on the line. They say, okay, read that again. More emphasis. Oh, you screwed up that word. You left out the comma. You changed the name of that person. And I also found out that I was mispronouncing the names of my students, and I'd been doing that for their whole time in my lab for the last 3 years. And finally, they told me that's not how you pronounce his name. And I went back and I said, "Have I been saying your name the wrong way?" And they went, "Yep, but I didn't want to tell you."
Oh man, that's really funny.
But it was worth doing. And actually, what we did in the audiobook, which I hope you enjoyed, was to put snippets in between the chapters of my co-author and I and how we came up with this book.
Yeah, I love those. They're very conversational, and I thought yeah they added a nice tempo to the book and provided some nice a break from like the science and kind of just a look at like the whole process and what that was like for you. So yeah, I loved that.
The process was pretty intense because Matt LaPlante, who helped me write it, he's a professional writer at Utah State University. I had to somehow download my entire brain, character, way of speaking into his. So we spent many months together on whiteboards in my office here, just doing that. And he brilliantly saw these connections between this story, that story, and he's a very good writer. And after he gave me the first draft, I would go back and I'd fix the science, make sure that it was correct, and put references in and add little extras that then he frustratingly had to fix. But there's no way that he could have written such a book, and there's no way I could have written such a book. This is a book that took three people an entire year or more to put together. And there's illustrations, there's drawings of the characters that I've put in the back. Actually, most people don't realize I drew those, but I did. And it's come off, I threw everything I had into this, and I'm a fairly fastidious perfectionist. And I'm really, really pleased with how it turned out. It's a secret. Most people don't know that, and I don't broadcast it. But what happened was I had photos of these colleagues of mine that I wrote about, and sketches from the internet. Some of them are historical figures. And Simon and Schuster, with 28 days to go before publication, said, "Oh, you can't use those. Those are copyright." I said, "Are you kidding me? What if I, find the photo?" They said, "Oh, you have to find everybody who painted it or took the actual photo." And 28 days, I'd never do that. So there were 28 characters, coincidentally. And so for 28 days, every day, I got home from work around 8, 9 p.m. and sketched one of the characters in my book.
You're talking about the people? No. You drew those?
Yeah, they're bigger in life size. They're about a foot high. And in the book, they're down to smaller than a postage stamp.
You drew these.
Yeah, each one every night. It took me about 2 hours for each one.
Oh my goodness. These are incredible. They look like photos.
Thanks. Well, your listeners know something that no one else does. You can
Wow.
download them off my website if you'd like to see them before you buy the book, or if you have the audiobook.
I'm very impressed right now. That is very impressive.
The website, I know people are thinking, what is the website? It's lifespanbook.com.
So for listeners, I will definitely put links to all of that in the show notes. But anyways, so to start things off into our conversation about aging and lifespan and all of the things, would you like to tell listeners a little bit about your personal health history and why what made you so interested in longevity?
Yeah, so my interest in longevity started very young. I think when we're all about 4 or 5 years old, we realize that one day our parents will be gone, everything around us will be gone. And that was pretty horrible. And not only that, my grandmother who raised me, she was a young grandmother. She was full of life, but she said, one day I'm going to get old and sick, and you're going to have to come visit me in a nursing home. And that was horrific. And most kids, as I've learned, uh, experience this same pain when they learn this, but very quickly they forget about it. And I think as a species, we tend to do that because you can't think about the horrors of being human every day, or it just becomes a little bit too much, I think. But I'm just one of those people that always thinks the world can be better and that humans can solve every problem if we just put our minds to it. And this was a big problem that I wanted to solve, not to live forever, but to allow people I love and people that in other families that are of course loved to not have to be spoon fed when they're old and bathed with a sponge. That's just horrible. We accept it and we call it natural, but that doesn't have to be the way our lives end. And so ever since 4 years old, I've been wanting to do this. I got a PhD in Australia, went to MIT, uh, and spent 4 years there working on yeast. And we discovered why yeast cells get old. And it turns out the same things that we learned about their aging process just recently we've discovered are very likely to be true in our bodies. And the same stresses on the yeast cells uh, that make them live longer work through the same genetic pathways that we discovered. And those exist in our bodies as well. So it's been 25 years. I'm now at Harvard. I've been at Harvard since I was 29. So I'm 50 now. So it's been a while. But it's a very exciting time. And the kind of discoveries we're making now, I didn't think that we'd see in my lifetime. And technology is going so fast, discovery is going so fast. And there are things that I didn't even anticipate, that things like there's a backup hard drive of youthfulness in cells that we can access and essentially reset the body to be young again. We're doing that in mice, and we'll be hopefully doing that in people a couple of years from now.
That is fantastic and super excited to jump into the nitty gritty of it. I did have a question right off the bat hearing you talk about that. And I loved how you talk in the book about your experience working with yeast. And I've heard you talk on other podcasts about how you grow sort of fond of these cells. How applicable are studies in yeast and rodents as far as like transferring the implications of that to humans?
Well, good question. There's really two questions in that. One is, does the biology of a yeast cell tell us about the biology of a human, um, or a mouse to a human? And there, it's absolutely uh, very similar, if not the same. In a yeast cell, there have been, I think at last count, 9 Nobel Prizes awarded for studies of yeast that have told us about our own biology. And I don't see why that's likely to be any different for aging and longevity and understanding how fasting works. Yeast are very similar to us. They have 16 chromosomes. We share a lot of their genes, a majority. And they struggle through life just like we do. We're built of the same stuff, essentially. But the second question, part of the question is, do drugs that have worked in mice or on yeast cells work in humans? And there it's different because we're sensitive to different chemicals, we have different microbiomes, and often drugs that work in mice don't work in humans. Diabetes drugs are typically more predictive than cancer drugs. Um, but really, what I'm excited about is not, are we going to have a drug tomorrow or in 5 years? It's, have we finally understood why we age? And are there things we can do in our lives now that will slow that process or reverse it? And I think the answer is yes.
I hope the answer is yes. Speaking to that, why we age. So historically, there have been a lot of different theories for why we do age. So things like natural selection or like the selfish gene theory, damage to DNA, different stressors. What are your thoughts on all the various, theories that have been proposed up until this point? And why do you think they are or are not painting an accurate picture? I know in the book you present aging as a disease, which is kind of a new way of looking at things. So do you think all these historical theories have like bits of them are true, or why are they not comprehensive enough? What are your thoughts there?
Yeah, so people have been studying aging in a comprehensive way for the last 50 or so years. Over the last 50 years, scientists have put forth more than a dozen theories about why we age. In the 1950s, 60s, it was all about radiation. That was the mode of the moment. Beyond that, it was free radicals and then mitochondrial damage. Then there was telomere shortening. And then more recently, people said, well, we don't know why we age, but we have a list of hallmarks. Let's go with that. And so about 10 years ago, we scientists all agreed that there are about 8 or 9 causes of aging, or hallmarks as we want to call them. And these are things that you would have heard of probably. Telomeres getting shorter and mitochondria get dysfunctional and DNA damage and all of those things. And finally, the field said, okay, if we can't agree on one cause, let's just say that there are 8 or 9 causes and be done with it. And we did that, and that was good because it stopped the infighting. And this field has been quite a vicious one over the last 20, 30 years. You know how scientists get; they fight over little things. Um, and But it's getting better actually because we now agree at least on a framework of what causes aging. But I wasn't satisfied with that. First of all of these theories have problems, which I describe in the book fairly briefly. For instance, the free radical idea, um, antioxidants haven't been very successful at extending the lifespan of a yeast cell or a mouse, let alone a human. And so that's been disappointing. But here's the main point that I want to make, and that is that I believe you can distill aging down to essentially an equation, a simple principle that can explain and unite all of these various causes that scientists agree happen during aging. And I call it the information theory of aging. And essentially, it means that the information that we get during our formation in the womb, the instructions to read the genome in the right way and read the right genes to keep us healthy, that information, which is called epigenetic information, is lost over time. And we've been able to test this hypothesis by messing up this information in a mouse and it gets old, and more recently, resetting the cell so that it reads the genes the right way and animals get their vision back when they're old.
I love this concept and this idea that you've come up with as with aging as loss of information. So for listeners, can you kind of paint a picture of what this looks like physically? Because I think people think genes, DNA, and then I think the epigenome is becoming more and more popular now with the idea of epigenetics, but I think it's kind of like ethereal the way people think about it, like epigenetics, environment, influences. Like it's hard to picture what that actually looks like on a physical cellular level. So what does that look like as far as like DNA, the genes, the genome and the epigenome?
It's really quite simple and beautiful. You just have to imagine yourself getting smaller and smaller. So if we do that, let's shrink down to the size of a cell, and we're now on the outside of the cell. There's a wobbly membrane. We can swim through that membrane, pierce a hole. Now we're inside the cell. Then we can see this bubble called the nucleus that contains the chromosomes. If we swim through one of the holes in that nucleus, we'll now see the chromosomes, and they're going to be vibrating around. They're quite energetic down at that level. And what the chromosomes are doing is that they're having loops of DNA that open up so you can access them. The cell can go in and read those genes in those loops. And DNA is just a chemical string that you can basically, it's not flailing around like a big ball of string. It's actually mostly compacted up, wrapped into little bundles with big loops that come out so that genes can be read. And when the cell needs to read genes, the loops come out and the cell reads those genes. And when the cell wants to shut off those genes in the DNA, it bundles them up tightly around proteins. And so it's very much like just beads on a string, and depending on how tightly you pack them, determines whether a gene is switched on or switched off. And that pattern of loops and bundles, is what dictates the music of our lives. Basically, that pattern determines whether your skin cell is a skin cell or your brain cell is a brain cell. The problem that I think is going on is that when cells get damaged, either by DNA damage or some other threat, and they need to quickly open up the chromosome and create lots of loops so they can read new genes. Or if the DNA is broken and they have to go in and repair it, there's all of this unpacking. And then after you've finished, you have to repack it back to hopefully how it was before. But every time you open up the chromosome and let the DNA expand into a loop and put it back together, it's similar to regifting. You can regift a present if you're very careful once, but if you regift a present 50 times, the wrapping paper is going to look pretty bad. And it's quite similar in that regard. And what happens to those cells over time is that instead of reading the beautiful symphony of the genes and those loops being perfect, coming on every time at the right place, they're all over the place. And now the cells are reading the wrong genes. And nerve cells forget that they're nerve cells, and skin cells forget they're skin cells because they're turning on these genes that shouldn't be on. And they're also turning off genes that shouldn't be off. And that's the epigenome. And that's the information that keeps us young. And I'm saying for the first time, I think I'm the first person to say that that process is what's driving aging and disease.
So now I'm just thinking about this picture that you've painted. So if there was only one option for genes to be turning on and off, okay, how do I say this? Like, would that mean there'd be less room for potential loss of information or damage? But because there's all these potentials of genes that could be on or genes that could be off or things that could be read or not read, that's why there's more likely slip ups because there's so much potential, so many things you could possibly do. So things have to go back to the way they were rather than a door just opening and closing.
Yeah, so early life forms could probably live for very long. Um, but it doesn't mean that just because you have more genes, you're going to have a shorter lifespan. Otherwise, we would only live a day and a yeast would live for 80 years, but that's not true. So, what cells have evolved are ways to stop the packaging from becoming completely unraveled and actually repackage it very carefully. And what we're finding is that long lived animals, there's a naked mole rat, this horrible looking animal that lives underground. It lives a lot longer than regular rodents. And its epigenome, these structures I've described, are much more stable over time. They managed to repackage them quite nicely. And probably if you go and look at another organism that's closely related to us, a bowhead whale, which lives 100 years longer than we do, they probably have a much more stable structure. The analogy that I also like to talk about is a pianist. And instead of having 80 keys on a piano, we have, 25,000 of these keys. And you can play them very differently to make different cells. As we get older, it's as though the pianist is playing the wrong tunes. But the piano is still there. And perhaps in the case of long lived organisms, the pianist doesn't make so many mistakes until much later in life. But what's exciting also is that we can now look at the pianist, we can read how she's doing, how she's playing. We can even fix her and make her play the notes that she did when she was young, which is great. But how she plays those notes seems to be a very accurate predictor of how long we live. And in fact, there are chemicals on DNA that control these loops called methyls. And the amount of methylation and the patterns of methylation on our genomes is a great clock. We call it the epigenetic clock. We can measure that. I can predict how long you're going to live. But the good news is that the epigenome, as you've hinted at, is malleable. We're not dictated by our genes. Actually, 80% of our lifespan is determined by how we live our lives. And that's because the epigenome is the major driver of disease and aging.
Okay, you touched on so many things there. I think people's ears are going to perk up when they hear the word methylation because, especially now, I mean, it's probably so complicated, but people will often focus on like MTHFR and they'll know that that's like a methylation problem. And I think that's probably like the extent of what a lot of people think when they hear methylation. Is that related to methylation? Is methylation a much more complicated process than that?
No, not at all. So methyls are used for a variety of chemical reactions in the body, but they're also used to store information. In the case of the epigenome, these methyl chemicals, which is really just a carbon with three hydrogens, nothing confusing. These methyls get added onto the DNA, and it's the cell's way of saying, I'm planting a flag on this gene, this is how this gene should behave. And typically, methylation will shut a gene down because it encourages the bundling up of the genes. But as we get older, those methyls, and if you should think of methyls like the plaque on our teeth, if we don't scrape away the plaque on our teeth, we're going to have a horrible mouth. Similar to our genome, we're going to accumulate this DNA methylation crust, and that's what causes the pianist to screw up, because the methyls are telling the pianist which notes to play.
The crust on the teeth thing actually made me think of something I was wondering when I was reading your book, because you talk about this concept and you just talked about it now. You talk about reteaching the piano player how to, play the piano without messing up. And you also talk about in your book another analogy that you provide is like a scratched DVD and losing information in the DVD. Would that be the same analogy or for the same situation?
Yes, yes, that's just another way. Um, I think there are a number of people, especially young people, who don't really know about DVDs that much, but they're a useful analogy that the genes are like the music, and the scratches are what happens during aging. And similar to an old cell that doesn't read the right genes, a scratched DVD isn't going to read the music very well. But the good news is that you can polish a DVD, and we also think you can do the same to our cells so that they read the music again.
So, question there, if it's a loss of information, is it just a matter of adding back the information? So like cuz like with the DVD analogy, it's like you're removing the scratches. So are you removing something that was lost? Are you getting rid of, are you taking off the damage, or are you adding back information?
Ah, you've just asked the most important question. So if someone can solve that, exactly how that works, I think they'd win a Nobel Prize. So only 2 years ago, we discovered in my lab that there's a backup copy of the epigenome. There's information in the cell that tells it where the methyls should be and which ones should be gotten rid of. So it's almost as though let's go back to the plaque analogy, that the dentist knows which is the good plaque and which is the bad plaque. Same with the cell. Those methyls, some of them are good because they tell a nerve cell to be a nerve cell, but there are others that are screwing up the cell. And what we know is that there are enzymes called the TETs, and those are enzymes that go and remove those methyls. And if we don't have the TETs in the experiment, in the cells or in the animal, we don't get the reset. So what that tells us is that part of this resetting is getting back to the original information that we had in the cell. But there's a backup copy of that. Um, so we didn't know that existed. You might ask me, well, how does the cell know how to get back those loops the way they were before? How does the cell know to take off those chemicals, those methyls at the right place, but leave all the others? We don't know the answer to that. That's the big question. We're looking right now. Where is the backup copy of youth in the cell? And I'll give you some ideas. It could be that there's some other chemical that sticks to our DNA that we don't know of. We're looking for that. There could be a protein that binds to our genome and says, hey, this is a youthful gene. Use me, come back, turn me on, or switch me off. We don't know what that is. We just know little pieces of this clock because it's only been 2 years since we discovered it. But we are making some rapid progress, and at least we know some workings of the machine.
Okay. Yeah, because that's what I was thinking about last night when I was like reviewing everything, because I was thinking about your theory and how it was this idea of returning back to the backup copy, so knowing what the cell is originally. But then I was thinking about things like scar tissue, where it's like a buildup of something else as well. So it's like, how do you get rid of this stuff that is extra, but then also return to the original state? And how do we know that there is a backup copy? Because of your work?
Yeah, exactly. Well, we're in a weird moment in history because I'm talking to you about research that's very, very new. In 10 years ago, before we had podcasts and before we had basically the whole of electronic publishing, this kind of research probably would have made it into a book 10 or 20 years from now, but you're all learning about it just as we're making these discoveries. In my book, I was writing down what it was like to make these discoveries as I was writing it. And so the reader gets a front row seat on what it's like to be a scientist and make what could be a really important discovery. Um, but yeah, this discovery is still new. We are the one of a few labs in the world that do this research. 5 years from now, I bet there's 100 labs doing this, but it's really, really early. And I could have kept my mouth shut. I could have said, no, I don't need to tell anybody about this. But there are two reasons why I did. The first is that I'm basing my conclusions on 20 years of research. So I've seen a lot, and we've actually got a lot of evidence that this is true. So I don't think I'm saying anything that isn't correct. The other thing is that my research is paid for by the public, majority of it anyway. So this is taxpayers' money. And I think we scientists have a duty to be able to communicate our research to the public and inspire people. I mean, why would anybody bother paying for experiments or starting a career in science if they aren't inspired by what we do?
Yeah, and I think that really, really comes through in your book because for listeners, in case you're wondering, a large portion of it, especially the beginning, is all of this science like we're discussing right now. But then you really go into the implications of your work in the future and like the implications for humanity. And it's really, really beautiful. So I applaud you for that. Going back to the clock that you were talking about, the genetic methylation clock, does that does that relate to the Yamanaka factors, or are those different?
It, it's exactly right. So the way that we can communicate to the backup hard drive, wherever it is through these Yamanaka factors. These are our communicators. And essentially, we've found the switch to the backup hard drive, but we're not exactly sure what's inside the hard drive. And these Yamanaka factors are a set of 4 genes that you can use to reprogram cells to be stem cells. This won the Nobel Prize in 2012. We don't want to turn our bodies into stem cells. We'd have a giant tumor in our bodies or die. So we need to we needed to figure out how do these Yamanaka factors, can they take us partly back towards youth? Can they take these methyls off? And if we do that, does that just make the cell seem younger, or does it actually reset the age of the cell? And do the cells function as though they're younger? And what we started to do was to, a couple of years ago, put 3 of the 4 Yamanaka genes into cells. We left one of them off. The fourth one is called MYC. That one is known to cause cancer. So for obvious reasons, we didn't include that one. But fortunately, those 3 genes were sufficient to take the age of those cells back and remove just the right methyls. So we saw that cells became younger. But that, taking cells back in age isn't going to win any prizes. It's not that exciting, even though,
I think it's
it's
exciting.
well,
Is
it was exciting, I have to admit. But what came next just blew that out of the water. I have a student who's still here in the lab getting his PhD, Wan Cheng Lu, and his dad studies the eye, and he knew a lot about the eye. And he said, you know what, David, the nerves at the back of the eye are a very good system to study age reversal. And I said, oh, why is that? And he said, because when you're very young, you're a baby, you lose the ability to regrow nerves. If you damage your eye as a baby, you're not going to, well, you might get your vision back. But if you do it as an adult, you're not going to get your vision back. Same for your spinal cord, same for your brain. Very difficult. So he said, let me reprogram the eye of an old animal and see what happens. If we're right, it should regrow back when it's damaged. And that experiment that was done, I think it's about 18 months ago now, he put the Yamanaka factors into the eye of an old mouse. Then they pinched the back of the eye to give it some damage. And he found that when he turned on these genes in the eye, the optic nerves at the back of the eye grew back, which is an extraordinary thing that was something we had never expected to work so well. The longer we leave it, the longer those nerves grow back. In fact, they grow back all the way back to the brain. And so, buoyed by those exciting results, we tried a couple of other experiments. We tested glaucoma. So you can give mice glaucoma, pressure in the eye that disrupts their vision. And we treated those with the Yamanaka factors and they got their vision back. And then we went for broke. We actually have a collaborator who works on the eye. He's the real expert, Bruce Cassandra. And he said, oh, come on, we're not going to reverse vision in an old mouse. You can't reverse aging. And we said, just do it and tell us what happens, kind of, you know, nothing to lose. And so he did it. And he called me at 10 o'clock at night and he said, David, I have to eat my words. The mice got back their vision as though they were young again. Perfect vision. This is incredible. I don't know how I'm going to sleep.
That is so fantastic. It's kind of like, okay, so you know how people with electronics, you can often get like refurbished versions of electronics, and people are always hesitant because you think if it's refurbished, yeah, it's like new, but it's refurbished, so it's probably going to break earlier. So are you seeing, like with your work, or like with that work with the eyes and the regrowing of the nerves, is it like it's completely like with no past? Like there's no evidence of any past damage?
It looks like it's a complete reset because we can do two things. We can go in and take those cells and read all of their genes and see which genes are on and off. Right? If we're correct, the loops that had gone awry and the bundles that had gone awry, messed up, they should all be reset. So then we can measure that by looking at which genes are on and off. And when we did that, it was a beautiful reset. It wasn't just a partial, oh, some of the genes go back. It was that genes that went down a little bit with aging after treatment went up a little bit back to normal. Genes that went way down with aging went way up with the treatment. And it's as though that memory was there, that genes knew how they should turn themselves on somehow and what they used to be a year before in that when the mouse was young. And that to me was the real proof that it's not just that we're making the cells healthier, but we're actually resetting the entire program. The other measure that we do is we actually measure the methyls on the DNA, and we can now do that pretty easily. And we can say, are those cells in the eye younger now after treatment than they were before? And we learned two things. The first was when you damage your eye, that accelerates aging, which is pretty cool. We didn't know damage to the body accelerates aging, but it does. And that our epigenetic reversal, the backup hard drive reset, uh, took those cells back to a younger state. But here's what I think you're wondering. How many times can you reset the eye? Or how many times do you need to reset the eye? And we don't know the answer to that. We're going to be testing that over the next 6 months to see if this is a permanent reset, and probably it is. We think it's addressing the very deep layers of aging. Um, but it could be that one time reset is enough or is all we can do. It won't work again. I don't think that's likely. But it could be that we could reset the eye 100 times. And if we can do that for the eye, imagine resetting the entire body 100 times. Now we're into territory where your mind starts to wander and wonder what would the world look like if this comes true.
Okay, super, super random question. I was recently listening to, I think, an entire podcast about the eye, and it was saying that we shouldn't wear contacts actually because of the damage they created to the eye. Does this at all relate to LASIK surgery? Is that completely different?
Yeah, I don't know if that's true.
I'm just wondering how that factors in.
Well, what I can tell you is that we're probably not going to be able to fix um, blurred vision or cataracts. I'd be surprised if we can do that. Well, maybe I shouldn't say never. Everything seems to be magical when we try, but the it just seems harder to remove those those inclusions, those damages in the cornea and in the lens. It's it might be true. I mean, the body is capable of great healing, so I shouldn't say never. But what we're showing is that the retina, which is full of living cells, are actually just lying dormant, and that we can rejuvenate those, and that they function quite beautifully just after a few weeks of treatment.
Gotcha. So it seems like which goes back to what I was wondering earlier. Is actual damage to things harder to address than, I don't know how it's different from aging, but how it's different from just resetting?
Well, there's all different types of damage. DNA damage seems to be the main driver of this process of the epigenome information loss, the repacking and unpacking. But there's other types of damage. One thing that's probably difficult to get rid of are misfolded proteins that accumulate in similar to like crystals in the brain, for instance. That's Alzheimer's. And what I predict and what we're testing is that sure, you might still have these protein crystals in the brain, but perhaps they wouldn't cause as much harm if the brain was still young. And so we're thinking about perhaps not being able to remove every accumulated piece of damage in the body. Maybe that'll work, we don't know. But even if it doesn't work, I'm quite certain that if you make cells younger, they'll be able to cope with that damage better.
Okay. So maybe it wouldn't be perpetuating like a chronic inflammatory aging state. It would just
Mhm.
sort of be there.
Right, right. And I think we'll find that the underlying cause of most diseases that afflict us is the loss of the epigenome information. We haven't looked at it. The medical community isn't even thinking about it. They don't even have the vocabulary to talk about it. But the reason that our tissues fail, I think, is largely because the cells lose their ability to read the genes the way they did when they were young. And as I mentioned earlier, damage to tissue accelerates the aging process, which is just going to make everything worse.
So correct me if I'm wrong, but did you say that you did a study in mice and that it was something about how like some of the mice had experienced damage, but then you use these factors to reverse it, and they actually lived longer than the controls that had never been damaged? Do you know which one I'm talking about? Does that ring a bell?
Well, we have mice that we can accelerate aging by the ice mice that we disrupt the epigenome. And we have molecules that stabilize the epigenome, such as the NAD boosting molecules. The one that I'm taking is NMN. And those mice are healthier um, and might live longer.
I wrote down that you turn genes on and off in some mice, and then it created damage. But then actually, when you reversed it, that they lived 40% longer than the controls.
Yes, so that was um, an experiment done by Juan Carlos Belmonte at the Salk Institute. And so probably Juan Carlos is going to get the Nobel Prize for this research because he was the first one who actually showed that when you turn on four of the Yamanaka factors, it can help an animal that's sick. Now, the reason that his results were not considered highly likely to be valid by most people, except a few of us, myself included, is that he used all four factors, and those mice that he treated would die after 2 days if he continued the therapy, which is not something I would advise anybody to do. And you'll recall if you use three of them, it's safe as far as we can tell. But he was the one that showed that when you turn on the four Yamanaka factors for 2 days a week and let the mice rest for five out of those seven, that those mice did live 30 to 40% longer. These were mice called progeria mice, where they have a mutation that accelerates aging in mice and in humans. Those, have you ever seen the progeroid patients? They're usually kids in their teens that look like they're 80. That's what they gave to the mice, and then they tried to reverse that, and they managed to do that at least 40%.
Wow. Crazy, crazy. Okay. And then, so you mentioned NMN, bringing this to more of like a practical level, like lifestyle tips and interventions and things that we can do to upregulate these anti-aging factors when it comes to genes. So I guess, well, so I'm also the co-host of the Intermittent Fasting podcast, and my book is largely about that. So that's one thing you discuss in your book is fasting, different dietary approaches, calorie restriction. Are pretty much all of these hormetic stressors, exercise, cold and heat stress, Are they all working on similar mechanisms as far as their anti-aging benefits?
We think they are. And going all the way back to 2002, we published a Nature paper that said, for the first time in yeast cells, we showed that heat and lack of sugar and energy and amino acids was working through the same pathway. And we think that's true for our bodies, that these are all turning on these longevity pathways. The ones that we work on, the sirtuins, these are the NAD requiring enzymes. It's one of the reasons that I try to maintain my NAD levels very high so that my sirtuins are active. And one of the questions that listeners might have is, what do these sirtuins have to do with what we just talked about? Well, sirtuins are the SIR in the name sirtuin stands for silent information regulator. And what they do is they create the bundles of DNA to turn genes off. And they're stabilizing the epigenome so that we don't lose that information to get older. And so the more sirtuin activity you have in the body, the better, and the slower you age. And if you make a mouse that has a lot of one of these sirtuins, it will live longer. In part, we think because the epigenome is longer lasting and you essentially don't get those scratches on the DVD. So that's how it all works. Now, the sirtuins do other things. They repair broken DNA and they fix old protein, get rid of old protein. But essentially, these are survival. This is a survival circuit, a very ancient one that evolved, we think, very early on the planet. And today, we can turn on these survival systems and epigenome stabilizers by doing the right things. Things that you mentioned, such as eating a lot less often, eating the right foods. You can take a sirtuin activating molecule, which is resveratrol, which I also do. Hot, cold treatments also seem to be hormetic. And the reason that these all work, and exercise, of course, I shouldn't forget, these all work, we think, because they're turning on these defense pathways that the sirtuins control.
And so the sirtuins, do they keep things quiet or do they repair things or they do both?
They do both. The problem for us and yeast is that the sirtuins have multiple jobs. And because there's not enough of them in the body, our body just doesn't make enough. They get distracted by various other things. So their main job is to, like I said, to control which genes are on and off. You'll find them sitting on the DNA, but they get distracted by things like a broken chromosome because they have to be released off the DNA and go over to where the break is and help repair that, and then they have to find their way back to where they came from. But they don't do that all the time. About 99% makes it back. 1% gets lost or gets stuck where it went. And we think that if you keep doing that, that's what messes up the structure of the DNA, and so that the cells can't read the genome anymore the way it used to. And so one of the major drivers is a broken chromosome, a broken piece of DNA, because that's going to distract the sirtuins, sequester them, pull them away from what they're supposed to be doing, and then they don't all find their way back.
I remember reading that in the book, you talking about them not finding their way back. And I was like, that's so tragic. Um, do you think that that could be a reason that people often get stuck in like chronic illness type situations because it's just perpetual damage and then constantly reaffirming this. I don't know, like does the damage continue to perpetuate the damage, and then with the sirtuins like going all over the place and they just can't deal, and then things just start continue to crash and burn, and maybe that's why it's so hard to get out of like a chronic illness situation.
Melanie, you should have been a scientist in my lab. I might have an opening,
Oh
but
man.
because you're hitting on all the questions that we're trying to address in the lab. So I'll tell you an experiment that addresses your question. We can take cells, we call them ICE cells, stands for inducible changes to the epigenome. We can turn on aging in those cells and age them rapidly in a day. And now these cells are like from an old person. Um, the interesting thing about that is that now the epigenome has all misfolded. But now we can ask your question, which is, are those cells now more likely to get additional DNA damage? And the answer is yes. As you age, you get more susceptible to DNA damage. Those loops And those bundles are essential to preventing further DNA damage. In fact, the more loops you have, the more exposed your DNA is to getting damaged. It loosens up the chromosome. And so, yeah, you're exactly right. We think that that's one of the reasons why we can be healthy till 60. And then after that, it's like falling off a cliff because it's this feed forward process that just gets out of control.
Hi, friends. I hope you're enjoying this amazing interview with David Sinclair as much as I enjoyed recording it. One of the things that we know about longevity is sleep is key. If you're not sleeping well, you're likely not aging well. Sleep is so important for so many functions in the body. It's even been posited that sleep ranks higher than diet, exercise, hormetic stress, anything else when it comes to the health of our body. And a lot of people struggle with sleep. Don't I know it? One of my early episodes of this podcast was with Dr. Kirk Parsley, who is one of the go-to sleep experts. He knows everything about sleep. I cannot recommend enough that you check out that episode. I'll put a link to it in the show notes. But he became interested in sleep after working with Navy SEALs who are notorious insomniacs. He formulated a supplement which provides the exact substrates your brain needs to naturally instigate the sleep process. So it's not a pharmaceutical that's just going to knock you out and make you think that you slept without really sleeping. Nope. On the flip side, this supplement actually provides what you need to naturally enter the restorative sleep state. It's called Sleep Remedy, and I cannot recommend it enough. Ever since I discovered it years ago, I've used it consistently and recommended it to so many people. And I do have a special offer for you guys. If you go to sleepremedy.com, you can use the code MelanieAvalon, and that will get you 10% off your order. So definitely check that out. Sleep is huge for longevity, guys. Huge. And before we get back to the show, just in case you missed those other Black Friday deals at the beginning of the podcast, those included 8 free grass-fed steaks, $20 off, 20 to 25% off the chili pad units, which, by the way, Dr. Kirk Parsley loves as well, 15% off site-wide at Beauty Counter for non-toxic skincare and makeup, and for the first time ever, $100 to $200 off various Juve, red light, and near-infrared therapy devices. Again, I talked about that all at the beginning, but I will also put links to all of it in the show notes. So yay, Black Friday. All right, now back to the show. Yeah, I mean, I've been researching more and more, especially the power of epigenetics and how even like mindset comes into play with all of that. And I just find it so fascinating, especially with the placebo effect, how people can experience such radical changes from things or like spontaneous remissions from diseases after something seemingly simple like a mindset shift. But I often wonder if it is because it's completely rewriting the program in a way. Like it's changing that perpetuation of all of the damage and starting things anew. Speaking of like the damage and the stress, and you talk about how some stresses are too big to overcome. You talk about like stepping on a snail, like you can't really overcome that. um, do you think it's possible for any sort of stress that we experience to be hormetic? And in theory, even like chronic stresses, maybe Lyme disease, heavy metals, things like that? Or are some stressors to the body always going to be negative, and then only some stressors could be hormetic and positive?
Well, it really depends on how much damage they cause and if the damage is reversible. Yeah, if you tip the scales to where you're doing more damage than good, and if especially if it's not reversible, then that you want to avoid. And that's why, besides stepping on a snail, it's also bad to take heavy metals, which will accumulate and continue to just cause problems. But I think that there are probably some other stresses we can give the body, and I don't mean psychological stress, I mean biological stress that we haven't discovered yet. There are certainly chemicals or molecules from nature that will trick the body into thinking that it's under adversity, under threat of survival. And just like resveratrol, there's probably thousands of those in the animal and the plant world that we can take. But yeah, it's an interesting question. What else can we do to maximize the hormesis? I like to joke that anything that doesn't kill you makes you live longer. That's not exactly true, of course. There are things that will make us sick that are not good and cause inflammation, that kind of stuff. But you get the principle that it's got to turn on the defenses of the cell and stabilize the epigenome without causing any lasting damage.
So resveratrol. So a lot of red wine fans out there. Do you think the resveratrol? I'm so excited. I'm talking to you. You're like the resveratrol guy. So that resveratrol, does it need to be supplemental form, or can somebody get an adequate amount of resveratrol from a glass or two of wine, maybe specifically a high stress varietal like Pinot Noir, or does it really need to be supplemental to get those benefits?
Well, it depends on what benefits we're talking about. If you want to treat diabetes, you're not going to get it from one glass of red wine, obviously, just to take the extreme view. But is a lifetime of red wine drinking beneficial? I think absolutely it is. It's small amounts. And red wine has a lot of other, what I call xenohormetic molecules. Um, these are molecules that signal to our body hormesis. Instead of us having to be stressed out, the plants can do it for us, and we get those signals. There's quercetin or quercetin, some people call it. There's a whole bunch of what we know as polyphenols that activate the body's natural defenses against aging. So that's kind of a long way of saying one glass won't make your life longer. It won't cure diabetes a day. And the amounts that I take are about 500 glasses a morning, which I please don't do that. I don't recommend doing that. That'll severely damage your liver. But I think as part of a healthy lifestyle, as long as you're not overdoing it, I mean, red wine's one of the healthiest drinks you can have.
Yeah, I think it's actually a case where, people will say, have just a glass here and there, but I think it might be something where consistently just having it as part of your lifestyle in, small to moderate amounts might be a healthy way to go.
Well, did you know, and this is not scientific, but did you know that the longest lived people typically say that they take in a lot of red wine, and if not red wine, it's some other polyphenol source like olive oil. So the longest lived woman, Jeanne Calment of France, lived to 122, ostensibly, and she attributed her longevity in part to a glass of red wine every day. And that's also true for the longest lived man, Antonio Todd, at 116. He also said a port wine every day was for him. So, it might be coincidental, but it kind of does fit with what we're thinking here.
No, I love it. And I think she also said something about some of her secrets were like laughter and then feeling like she was, like could handle anything. So she wasn't like scared of stressors. She always felt capable, and maybe that ties back into what we were saying about what you were saying about, what doesn't kill you makes you live longer, and just the whole perspective of everything.
Yeah, the way I think of it is reduce mental stress, but biological stress is fine. And because they're different things, just because we have the same word for it doesn't mean they're the same. And so in my life, I'm doing as much as I can to wake my body up. I'm here at a standing desk in my office every day. I'm running on weekends. I'm jumping into hot tubs and sauna, bathing. So that's all good for my body. Mentally, though, and I haven't often talked about this, I'm a very different person now than I was 20 years ago. I was the biggest stressor of bad moods, lack of sleep, constant worry. Um, Even as a teenager, so bad, basically suicidal. Now I'm just very happy, content, can live with stress of the day. And, partly it's maturity. You know that things are never as bad as they seem at the time. But it's also because I'm actively making sure that I don't worry.
No, I think it's so huge. And ironically for me, I feel like I I feel like like for the longest time I had the mindset of I wasn't really stressed by things chronically. I felt like I could really handle anything. And it wasn't until I started, I actually read a whole book about how stress was really bad for you, like chronic stress. And then I started stressing about chronic stress. And that was a very, I should have never done that, because then it's like you said, I almost wish there was a different word for chronic stress and physical stress, because I think that could, I mean, I really think that could be a game changer. Even like if like kind of like calories, or the difference between, or the word fat and like difference between dietary fat and fat in our bodies, but using the same word stress to define physical stress and to define mental stress, I think they're so different. And I think the perception of it is huge, and I agree that the physical stress, I think, can be like a wonderful thing for our bodies. And then it's that worry and that mindset, which I think can just do a number on you. Speaking of stress, intermittent fasting, calorie restriction, things like that. So, as you know, I've been on the intermittent fasting bandwagon for quite a while. I've been doing it for about 10 years now. And so something I was wondering was, in your book you talk about being hungry being supportive of longevity, so be that from fasting or a calorie restricted diet, for example. Do you need to actually feel hungry? Because you talked about those studies where they're calorie restricted, but because of like the content of the diet, it suppressed their hunger signals, so they felt full and they didn't experience the same effects from longevity. So like when it comes to intermittent fasting, what if somebody it's really working for them and they're not hungry during the fasted state? So is it real hunger or perceived hunger that's important?
Mm. Well, we don't know, but I'm working on it. What it,
Oh, really?
yeah, what
Okay.
it seems to be that uh, you don't have to feel hungry to get the benefit, but your body needs to perceive low energy, right? Because hunger isn't always associated with low energy. And for instance, I've got this glucose monitor that I'm trying out, and this one, the Libra Link, the one that it's a little patch under your arm that gives you a constant readout.
I
And
need to get one of those so
oh,
bad.
they're so interesting. Anyway, so I'm going to take a reading under my arm, just here, under, yeah, on my arm flab here. And so I'm looking now at my phone, which has now registered the last few hours of my day. And so my blood glucose level has hovered the whole day around 100, which is good. You don't want it to go much above that. Now, what's interesting is I can see on this when I'm getting hungry and when I'm not. And I can tell you that it doesn't always correlate. I can have really nice low blood sugar levels and not feel hungry. And it often depends on my state of mind, but also can depend on what I ate. So often, if I eat a plant meal, so today I had a tiny little vegetable soup, my glucose levels stayed nice and low, but I'm not hungry. And so I think that my guess is my body is getting the benefits of low glucose, and I don't have to suffer during that process.
So you think it's a blood sugar related thing? Like low blood sugar?
Well, part of it's blood sugar, and part of it's got to do with insulin. But really, what I'm aiming to do is to get my mitochondria activated, my AMP kinase pathway that is upstream of that activated. And that gets activated when cells have low amounts of energy in the form of chemical ATP. And so I'm trying to use glucose as a surrogate measure of low energy in my body. And having low energy, um, it'll be compensated by the body by revving up metabolism and making its own energy, which is what I think is the healthiest way to exist.
Okay. So for somebody in like the flip side situation, because I know especially with like the obesity epidemic, and people may feel like they have insatiable appetites even though they're eating, way above their metabolic needs. I'm guessing it's safe to say that's probably not supportive of longevity, even if they're experiencing seemingly hunger from it.
Exactly. That's the other side of the coin. What we have seen in animals and in humans is that obesity is the best way to shut down your sirtuin defenses and accelerate that epigenetic clock, the loss of information in your body. Um, I haven't been super thin my whole life, but now that I'm thinking about things in terms of sirtuins being active and the epigenome, I am really trying hard to to have the minimum amount of fat in my body.
Okay. And then that also ties into, I have so I've been thinking so much about like metabolism, thyroid, things like that. They're proponents when it comes to metabolism and growth and even like reproduction on both sides of the coin. There's some people that say, lower metabolism is better for longevity, like a lower metabolic rate at least. Like we'll often see that on a like a ketogenic diet, for example, and that low T3 levels are correlated to longevity. But then there's the people that are saying, high metabolism is really important for longevity. What are your thoughts on metabolism and longevity?
Well, what we've seen is in our studies over the last 20 years is the correlation between longevity and metabolism is the following. Uh, Longer lived animals have much greater insulin sensitivity and mitochondrial activity. Okay, and so they're actually burning more oxygen, and calorie restriction will do that too. Now that doesn't prove that that's what the reason that they're living longer, but it's a very strong historical correlate. Um, and so I've always been of the opinion that having more mitochondria and increased insulin sensitivity and lower fasting glucose levels are going to lead to a longer life. Um, there's a product called acarbose that lowers the amount of sugar that cells are able to take up, and that extends lifespan in mice. So, I think it's the best I can say is that the science points to having highly active mitochondria, but not mitochondria that are spewing out free radicals, ones that are hyper tuned by hormesis, like exercise, or um, even metformin will actually reduce free radical damage. Um, Metformin we haven't talked about much, but it's a way to trick the body into thinking it has low amounts of energy, and it'll rev up the mitochondria as a result.
Okay, that makes sense. So they're basically they're efficient and they're generating a lot of energy, but not necessarily a lot of extra oxidative energy. So what are your thoughts on mitochondria generating energy from glucose versus ketones, for example?
Ah, well, I think ketones are very important. I am totally in sync with you on that. That ketones will be high in animals that live a long time when we fast them. And getting back to the epigenome, there are modifications to the proteins that bundle the DNA that are ketones themselves or ketone-like molecules, such as butyrate. And there's more and more evidence that high levels of butyrate are helpful. Another one is acetate. Acetate, like acetic acid, basically, what you throw on British French fries, chips. That molecule also can be attached to the epigenome and help control it. And it looks very much like it when you're fasting. Those modifications on these proteins are very good things, and that we want to be able to control those with quite high fidelity.
Yeah, I was going to ask you a lot of questions about like the carnivore diet, for example, but then you're actually on my friend Paul Saladino's podcast. So that made me really happy. I was like, yay. I get to hear his thoughts on all of that in detail. So for listeners, I'll definitely put a link to that in the show notes. Hey guys. So, as we discussed, if you are at all familiar with the health benefits of red wine, thanks to a little compound called resveratrol, it's probably thanks to David Sinclair. He's the guy who did all the research to bring the health benefits of resveratrol to the spotlight. I've been a red wine fan for quite a while. It's been linked to longevity, so I was pretty excited to discuss it with him. Of course, that said, if you really want the health benefits of wine, most wine you're drinking today, especially in the US, could actually be causing more harm than good. That's because most conventional wine is actually rampant in additives and toxins and is often high in sugar and alcohol. Plus, conventional farming methods actually decrease the amount of beneficial polyphenols in the wine. After we recorded this episode, one of the first things I asked David was if he was a drinker of dry farm wines, which is the only wine I personally drink, because they're tested to be free of toxins, free of mold, low sugar, low alcohol, and honestly just make you feel fantastic. And because they are dry farmed and don't use pesticides and conventional farming methods, it actually upregulates the stress potential in the plants and thus the amount of resveratrol and other beneficial compounds in the wine. David actually hadn't tried them and he was super excited and said that they are finding the wines that are exactly what he was looking for. So it was a good moment. So if you'd like to try dry farm wines, you can actually get a bottle for a penny. Just go to dryfarmwines.com/MelanieAvalon and that link will get you a bottle for a penny. So raise a glass to health, longevity, all the things. All right, now back to the show. You did mention metformin, and because we didn't even talk about like NAD much, NMN, NR, all these different potential interventional supplements one could take to support longevity. Out of all of it, so you use NMN or do you use NR or NAD? What about NAD patches?
Ha. Well, okay. So, first of all, before I forget, um, on page 304 of my book, it's all listed out what I do. So, if I forget to mention something, you can go to the cheat sheet. But do go back to part 2, which talks about what you need to do to augment that and what might be good for you. So, NAD. So, NAD is required for sirtuins to work. When we exercise, diet, it goes up. When we get older, we think it goes down. So NMN is the immediate precursor molecule that cells use to make NAD. And cells, if you go back one step, NR is what cells use to make NMN. So it goes basically from the start, which is actually vitamin B3 or niacin, gets made into nicotinamide riboside NR, which gets made by the cell into NMN, which is nicotinamide mononucleotide, and then that's converted to NAD. And scientists are fighting over all the usual minutia because the stakes are so low, and they're arguing about which molecule's best, which one's taken up by cells, where it's taken up. Now that's all good. I'm not saying we shouldn't study it. I think some scientists, my colleagues, should be a little less aggressive about it. But nevertheless, we can figure that out. But also, let's look at what is closest to the actual molecule. So NAD is NAD, that's the final molecule. The reason that NAD may not be the best, we don't know, but may not, is because it's a big molecule and it doesn't easily get into cells. But I'm open to the idea that maybe it can be taken up or degraded and taken up that way. One step back, NMN. That's what I take. Why do I take NMN? Well, we've been studying it for the last 15 years, so I have a lot more information about it than anything else. But I also know that NMN has a phosphate attached to the molecule, whereas NR is lacking the phosphate. And I'm taking a large amount of NMN, which is a gram a day. I don't want my body to have to search for a gram of phosphate just to fulfill my supplementation. And so that's what little concerns me about NR. Now, others have argued and put out on the internet that NR is superior. First thing I'd say about that is whoever's giving you that advice, check that they're not affiliated with companies. I don't affiliate with any supplement companies so that I can give unbiased advice. Never have received money from a supplement company and hopefully never will. The NR is possibly able to help with longevity, but I will say that there are now at least 3 clinical trials in people where NR hasn't had a big effect on metabolism. It's lowered inflammation quite effectively, but the kind of things that we see in mice, such as endurance and mitochondrial activity going up, have not been recapitulated yet with NR. And that's another reason that I'm thinking maybe NMN, if it does work, is the superior molecule. But either way, let's just see what the data says. And then finally, the very simplest molecule is vitamin B3 or niacin, also known as niacinamide or nicotinic acid or nicotinamide. Um, I wouldn't take high doses of nicotinamide because it actually inhibits sirtuins. So that I would avoid. But also, these other precursors are very simple molecules, and the body has to build them up using ribose and then phosphate. And these are things then the body has to pull from other places or synthesize. And that actually turns out that's why they don't raise NAD levels the way these other molecules do.
Okay. I have some NMN sitting in my, well, it's in my refrigerator. Is it supposed to be refrigerated?
Please do. Yeah, NR is the most unstable. If it gets a little bit of moisture, and even if it just sits at room temperature, it will go bad after a few months. It's losing the nicotinamide. So the vitamin B3 part of it falls off pretty easily. Keeping it either in the freezer or if not the fridge is the best way.
I haven't taken it yet. I was like, I'm going to wait and talk to David Sinclair.
People wrote to me, have written to me and said, "Oh, I just bought it from the company. Is it ineffective?" Probably not. It still takes a few weeks for it to go bad. But I think for long-term storage, yeah, you definitely don't want to have it sitting on the shelf and not let it get exposed to the air at all.
Can you take it in the fasted state or with food?
I do. Yeah. I do that to enhance my NAD levels. And the important thing about NAD levels is that they cycle through the day. They'll start going up when you get hungry in the morning. And I want to just accentuate that and get the peaks higher. And so I take my NMN in the morning when I skip breakfast.
Would it absorb topically, do you know, or does it need to be?
It probably does get absorbed somewhat because it's a small molecule. But I don't know if anybody's tested that. I've seen some products that have NMN in facial cream, um, but I haven't seen proof that it gets in. Why do you rub it on your face?
Well, I haven't used it yet, but I'm just sort of becoming obsessed with the idea of topical application when possible, but mostly due to my less than perfect GI state. So I'm like, what can I take topically?
It's a good idea, and I've been using some creams that we developed in my lab for the last 10 years, and um, I'm apparently not super wrinkled, so it seems potentially to have helped. But yeah, I agree that you should be able to activate these defenses in your skin just like we can do with these molecules when we eat them.
One really quick rapid fire question that I've been dying to ask. It's been posited that too much fasting could actually deplete stem cells. Do you think that's a problem with daily intermittent fasting?
No, but I don't have proof of it, but it sounds against everything that I've learned over the years.
Do you think it would extended fasting be a potential for depleting stem cells?
Well, let's look at the results of intermittent fasting. There are Greek Orthodox um, that fast for many days. I have no, and maybe you do, but I have no evidence that people and communities that fast for short or long periods are losing their stem cells and dying early. It's the opposite. These are the longest lived people on Earth. So I don't see how anyone can argue that we're hurting ourselves by fasting.
Okay, no, I agree. Good to hear that. Okay, two final questions because I know your time is super valuable. One, bringing everything home. So, say there was a society where people happened to live till they were 200, like that was just what was normal. And then and that was due to their biology. But then you had like a person who actually had our biology today put in that society, but they didn't know they had like our normal biology. So they thought it was normal to live to 200. Um, do you think in that situation that person might live to 200 just because of the epigenetic potential of mindset, the environment, things like that? And then on the flip side question would be, what if there was somebody who you actually did all of this genetic manipulation to live to be 200 in today's society, but because of their mindset, maybe they thought they were, had a chronic illness or a disease or something? Is it possible that they actually would get old and die really early because of their mind?
Wow. Okay. Well, stop me if I don't answer everything you just said. But starting with the first one, um, it looks like we have about 20 to 30 years to play with. with how we look after ourselves. We know the maximum human lifespan is 122, and the average is 80. So that's a long gap to be playing with. And it's been shown in twin studies that 80% of your lifespan is in your own hands, and you can have a big impact. So, how much of an impact? I mean, based on a lot of studies in monkeys and in rodents, um, probably you can only extend your lifespan by about 10 to 20% by leading a good life. Maybe if we learn more and the combinations of various things, we'll get even further. But I don't think we're going to be able to double our lifespan just with a positive attitude and doing some good things. I think that's too much to ask. Our biology, our genome is too powerful to overcome these changes to the epigenome. Even if we have the best epigenome, our genomes are still going to do us in. But imagine if we could engineer somebody to live go from 80 up to 200. I think that's doable because whales do it, and there may be just some genes that we could strengthen the epigenome and allow us to live much, much longer. Because if I'm right and the epigenome is the main cause of aging, as long as we stabilize it, all these other causes of aging and disease should go away or at least be slowed down dramatically. And then finally, I just want to say that these are really good thought experiments because they also open up your mind to why it's silly to call aging something different than disease. Because that person who's in a society where everyone lives to 200 and they're 80, they're going to be regarded as having this horrible condition. And of course, the FDA is going to approve a drug, even a gene therapy to help them live like the rest of us. But because we all only live 80 years, the FDA and the medical profession says, that's natural. That's what we should deal with. But imagine a world where we all live that long and only a few people lived 80 years. Then that would be a disease that we'd raise money to try and treat.
Exactly. And then for the flip side, a person who you do all the genetic manipulation to. So in theory, they should live to be 200, but they're convinced that they're sick and dying.
Well, they could probably counteract all the good research and medicines that we gave them if we changed their epigenome to live 200, but they sat on the couch and became giant and obese and didn't do all these good things we've talked about today. Yeah, you can shorten your lifespan, no question. It's pretty easy to shorten your lifespan. It's lengthening it that's the hard part.
All right. Well, thank you so much. So, the last question that I ask every single person on this podcast, and it's because I realized how important mindset is when it comes to health and longevity and just everything. So, what is something that you're grateful for?
Oh, well, there's 1,000 things. I'm grateful that I found a soulmate who puts up with me. I'm not an easy person. I'm often obsessed and busy, and she's tolerated me for more than 20 years. And then we have a great 3 kids that we've managed to produce, and so far not to kill them. So I'm grateful for that. That's what makes my life worth living. But then on top of that, the real cherry is that I'm grateful to have a career to do things that I would do for free, but I get paid for. It's super fun every day trying to come in and discover things about the world and leave the world a better place, hopefully.
Well, that is wonderful. And thank you so much. I am so grateful for your work, for everything you're doing. I've been looking forward to this interview for so long and it was so magical for me. And I will eagerly be following all of your work from here on out as I have been. And so for the audience, how can they best follow your work?
Well, yeah, the book gives you the best primer and foundation for what we're going to be talking about going forward, and how to live your life today to extend your healthy life. I'd start with that. The audio book people seem to love. Listen to it in the car. Additional things. So the field is changing very quickly. So I update folks on my website, which has a newsletter. So you can sign up for that, lifespanbook.com. And then day to day, I'm also on social media. So I'll post various things on Instagram where I'm David Sinclair, PhD, and on Twitter, a few times a day, I'm sending out either new discoveries or things that are tips to live a longer life. And that's David A. Sinclair.
Awesome. So for listeners, I will put links to all of that in the show notes. And again, the show notes will be at melanieavalon.com/lifespan. Well, thank you so much, David. This has been absolutely amazing. I'm just so happy right now. I can't even describe.
Yeah, I was hoping to meet you too. This has been great. Thanks, Melanie, and continue what you're doing because it's science-based, and not everyone says what you're saying, but it totally fits with our research.
Oh, well, thank you, and you as well. Thank you.
Thanks.
Bye. Thank you so much for listening to the Melanie Avalon Biohacking Podcast. For more information, you can check out my book, What When Wine? Lose weight and feel great with paleo-style meals, intermittent fasting, and wine, as well as my blog, melanieavalon.com. Feel free to contact me at podcast@melanieavalon.com. And always remember, you got this.